If you're listening to this, you probably already know I'm not here. But I have a mission for you. But before we start, I'm going to let Mr. Kolb refresh our memories. Mr. Kolb. Thank you, Mr. Kolb. If you look behind me, you should see what is behind you. You see what I did with that? Behind me, behind you. Ah, get it? Forget it. The first formula we covered, speed and velocity. We'll go over this very, very quickly. Get it? Speed, quickly, get it? Get on with it! Fine, fine. So when you change your position, you have a velocity. Oh, Mr. Kolb, nice of you to join us. Whatever. Hey, Mr. Kolb, I have a question. Yes, Mr. Kolb? That's not how we learned it. Speed is distance over time, not position. What is this position thing? I can field this one. Thanks, Mr. Kolb. You see, distance is not a position. A position is where you are. That's where you are. That's where you are. A distance is what lies between. So you can cover this distance no problem. But these two are positions. You can start at position 0 and then go to position 40. Your distance would be 40. If you start at position 10 and you go the same distance, 40, you will end at position 50. That's what we like to call your final position minus your initial position. Now this little 0 stands for initial. Final position, initial position. And that's going to be your distance. This is also known as delta x. The delta, all it means is the difference between these two. Which brings us to our next concept. Whoa! 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 We didn't go over the objective yet. Fine. Take it away, Mr. Kolb. Thanks, Mr. Kolb. Today's objective is to understand the concept of acceleration. Yes, Mr. Kolb. Isn't acceleration the same thing as velocity? No, it isn't. Acceleration is the difference between and that's why you should never tango with a baboon. I am so lost. I never knew you could ride an elephant like that. And your unintentional involvement in the Cold War? You should write a memoir. Still lost. What's a memoir? Look, you explained acceleration horribly. Why don't you let them take a crack at it? Them? Yeah, them. The kids watching this. It's an idea. Fine, that's settled. Here's your mission, to figure out for yourselves what acceleration is. Here are your parameters. Work within your table to come up with a definition for acceleration. You have 2 minutes. Good luck, and Godspeed. I still don't get it. What is acceleration? For those of you who haven't figured this out yet, your notebooks should be out. It's the change in velocity over time. Acceleration is the change in velocity over time. The change in velocity over time. The change in velocity over time. So what you're trying to tell me is that acceleration is the change in velocity over time. Yes, over time. So that's great and all, but how do I use it? What can acceleration do for me? When we have all the equation of kinematics down, kinematics is what we're doing now, we can determine the muzzle velocity of the gun. Big deal. You can use a radar gun for that. Do you have a radar gun? No. You can do it without a radar gun. You can use a timer. No problem. I got this. Are your reflexes fast enough? Well, no, but you can do it without a timer. Fine, whatever. I think we need an example problem to elucidate this elusive. Example. I was on the Garden State Parkway. Not another Garden State Parkway problem. Fine, fine. New Jersey Turnpike. Mr. Kolb, I think you're missing the point. Why don't you tell them about that roller coaster you went on over the summer? Over the summer, I went to Pennsylvania. And that's how I met Michael Vick and received the key to the city. Mr. Kolb, you didn't even mention the coaster. Right. The roller coaster's name is Fahrenheit. For simplicity, we will do this in metric. So, we're converting Fahrenheit to Celsius? No. We're converting Fahrenheit to metric. That's what I said. Fahrenheit is a name of the roller coaster. It does a hairpin up top and it goes straight down. It shoots you up and then shoots you down. question is, what is the acceleration experienced at the very beginning of the coaster? Work in partners to figure this out and work it out on the board. This should take you between 2 and 5 minutes. Now, there is homework, but you'll get to that soon. Yeah. Welcome back, if you're watching this. You did that already. Right. While I find my place, Mr. Kolb will demonstrate the problem on the board. Now, it says that it goes from 0 to 60 in 2 seconds. 0 to 60 in 2 seconds. Here it's going 0 miles per hour. Here it's going 60 miles per hour. And it says it can do it in 2 seconds. So let's use the formula. Acceleration equals change in velocity over time. What's our change in velocity? Well, what's our final velocity? 60 miles an hour. What's our starting velocity? That's right, boys and girls, it's 0. And finally, what is our time? 2 seconds. Now, the units will get tricky for this, but it'll be a very, very simple answer. Over here, it's going to be 60 over 2. And what's 60 divided by 2? Yep, it's 30. 30. So here's our answer. But what's our units? Well, it's miles per hour per second. Miles per hour per second. Some unit, right? You said per a lot. Can you explain that? So what per means, if you remember, per is that line that goes between the numerator and the denominator. Remember, the numerator is how much you actually have. The denominator denotes the numerator's value. If that's confusing, ignore it. So the numerator and the denominator. So per is this line over here. So you have x over y. This line is per. X per y. So say you're speeding up. Say you're on the ramp. And it takes you 2 seconds to speed up from 45 to 65, like on the Garden State Parkway. So it's a difference of 20 miles per hour. They increased your speed by 20 miles per hour over the course of 2 seconds. So you did 20 miles per hour per 2 seconds, or 10 miles per hour per second. Now, there is homework. The homework will be collected and checked for completeness. You may work on it until the end of the period. Goodbye, and I will see all of you tomorrow.